How-to videos are a popular source for task learning. People learn new skills such as cooking, knitting, or using Photoshop through videos, as they provide detailed and step-by-step workflows. When learning a task, people typically start with understanding the procedure of the task and then applying it in their specific context through execution. In the first phase, people gather and process information to develop an understanding, and they often do so by watching or skimming multiple videos. Watching multiple videos on a task can significantly enhance understanding of the task since it offers diverse perspectives and insights. By watching multiple videos, learners can learn about different methods, tips, or techniques. However, watching multiple videos poses challenges. Most video platforms present videos independently in a linear format, which isn't ideal for task learning. Unlike entertainment videos, how-to videos require structured navigation and connections between the content. But processing large amounts of unorganized information is time-consuming and overwhelming. To address this, we first conducted a formative study with 12 participants to gain insights into how users learn new tasks through multiple how-to videos, and to understand the specific information they seek across these videos. Based on the findings, we present VideoMix, a system that helps users gain a holistic understanding of a task by aggregating and organizing information extracted from multiple videos on the task. Here is a detailed walkthrough. Let's say the user wants to learn how to build a desk. After selecting a task, VideoMix provides information extracted from dozens of videos. First, it presents video search results categorized by outcome types. Once the user selects an outcome type, they see three approaches: standard, the most common method; simple, the one with the fewest steps; and complex, the one with the most steps. Let's say the user chooses the standard approach for a modern and sleek design. VideoMix displays the required materials, ingredients, and tools, with the colors representing its frequency. Below, users can see a step-by-step breakdown of the chosen approach with brief descriptions for each step. Clicking on a step opens its details page. Here, users can explore different methods to complete the step. Selecting a method brings up video snippets relevant to that method. Users can easily switch between videos for the selecting method, with the corresponding time frame playing automatically. Users can also see tips and notes extracted from the videos. VideoMix organizes information from multiple how-to videos using a vision language model-based pipeline. Given a set of videos on the same task, for example, building a desk, it first identifies the different types of outcomes of the task through visual and narration of the videos. Then, for each outcome type, VideoMix determines standard, simple, and complex approaches to achieve the desired result from the videos that correspond to that outcome type. Until this process, videos are clustered into different sets. Next, once a video set is determined that follows each approach, VideoMix identifies parts of videos that correspond to each step in the approach. For each step, it identifies different methods employed in the videos, along with additional details such as tips and notes for each method. In this process, video segments are clustered into different sets. To identify possible sequences of steps that may vary across different videos, we introduce a dynamic approach identification module. Our DAI module first starts by extracting step information from the first video using GPT, and the step taxonomy is refined iteratively by comparing it with subsequent videos. Once it is finalized, the taxonomy is applied to all the videos to align relevant steps. Finally, it identifies standard, simple, and complex approaches based on the number of steps and video coverage. Results of the technical evaluation of our DAI module show that our pipeline maintains step accuracy while capturing a significantly more diverse range of possible approaches. A user study with 12 participants showed that VideoMix improved perceived learning performance and efficiency. They found it more useful for understanding tasks compared to the baseline.